Welcome to this lesson on the applications of differentiation. By the end of this session, you will be able to find the gradient of a tangent, determine the equation of a tangent to a curve, and find the equation of the normal to a curve at a given point. These are essential skills for your IGCSE exams, as they bridge the gap between pure calculus and coordinate geometry. Let's start with the fundamental idea, the gradient of a curve. In this first section, our goal is to use differentiation to find the gradient of a tangent at a specific point. Recall that the derivative, dy by dx, gives us a formula for the gradient of the curve at any point x. A tangent is a straight line that just touches a curve at a single point and has the exact same gradient as the curve at that point. So, to find the gradient of the tangent, we simply calculate dy by dx and substitute the x value of our point. Let's look at this example. First, we differentiate the function. Using the power rule, the derivative of 3 times squared is 6 times, and the derivative of minus 4 times is minus 4. The constant 1 disappears. Now, to find the gradient at the specific point where x equals 2, we substitute 2 into our derivative. This gives us a gradient of 8. This means at that exact spot on the curve, the slope is 8. Notice how we use the derivative as a tool to find a specific numerical slope. Now that we can find the gradient, let's move to our next objective, finding the full equation of that tangent line. Remember, a tangent is a straight line. To find the equation of any straight line, we need two things: its gradient, which we call m, and a point that it passes through, which we'll call x1, y1. We use the point gradient formula shown here. Let's apply this to a past exam-style question. Example 2. Find the equation of the tangent to the curve y equals x cubed minus 5x plus 2 at the point 3, 14. Step 1. Find the gradient by differentiating. Step 2. Substitute the x-coordinate of our point, which is 3, into the derivative to find m. m equals 3 times 3 squared minus 5, which is 3 times 9 minus 5, giving 27 to 5, which equals 22. So the gradient of our tangent is 22. Step 3. Plug the gradient m equals 22 and the point 3, 14 into our line equation. Expanding the brackets, we get y14 equals 22x 66. By rearranging, we get the equation y equals 22x minus 52. Take a moment to see how the calculus gave us the slope, and then coordinate geometry finish the job. Next, we will extend our knowledge to find the equation of the normal to a curve. In geometry, the word normal means perpendicular. A normal to a curve at a given point is the straight line that passes through that point and is at right angles to the tangent. Because the tangent and normal are perpendicular, their gradients have a special relationship. If the gradient of the tangent is m, then the gradient of the normal is the negative reciprocal. Think of it this way: if you know the tangent's slope, you flip it and change the sign to get the normal slope. Let's work through a full example. Find the equation of the normal to the curve y equals 8 over x at the point where x equals 2. First, we need the y-coordinate. When x is 2, y is 8 divided by 2, which is 4. So our point is 2, 4. Next, we find the gradient of the tangent. We rewrite y as 8 times x to the power of minus 1. The derivative dy dx is minus 8x to the power of minus 2, which equals minus 8 over x squared. Substituting x equals 2 into the derivative gives the tangent gradient as minus 8 divided by 2, squared, which is minus 8 over 4, equaling minus 2. Now, find the gradient of the normal. Since the tangent gradient is minus 2, the normal gradient is negative 1 over minus 2, which is 1/2. Finally, use the line equation with the point 2, 4 and the new gradient 1/2. Expanding the brackets gives y minus 4 equals 1/2 x11. Adding 4 to both sides gives y equals 1/2 x plus 3. The equation of the normal is y equals 1/2 x plus 3. Notice that the process is identical to finding a tangent, except for that one crucial step of calculating the perpendicular gradient. To wrap up, let's look at a more complex example similar to what you might see in the latter half of an IGCSE paper. This question combines everything we've learned. Here is the exam question. The curve C has equation y equals 2x squared minus 8x plus 9. The point P on the curve has x-coordinate 3. Find the equation of the normal to C at P, giving your answer in the form ax plus by plus c equals 0. Let's break this down into 4 clear steps. Step 1. Find the full coordinates of point P. When x equals 3, we substitute it into the original equation to find y. Y equals 18, 24 plus 9, which simplifies to 3. So, point P is at the coordinates 3, 3. Step 2. Find the gradient of the tangent using differentiation. The derivative dy dx is 4x minus 8. Substitute x equals 3 into the derivative to find the tangent gradient. Step 3. Find the gradient of the normal. Since the tangent and normal are perpendicular, we use the negative reciprocal of 4, which is negative 1 over 4. Here we can see the curve, point P, and the normal line we are calculating. Step 4. Find the equation of the line. Using the point slope formula, we have y minus 3 equals negative 1/4 times x minus 3. Multiply everything by 4 to remove the fraction. Expand the brackets to get 4y minus 12 equals negative x plus 3. Finally, rearrange it into the required form, where all terms are on one side. Notice how we carefully followed the requested format. In your exam, always check if the question asks for y equals mx plus c, or the general form shown here. You have now mastered finding the gradient of a tangent, finding the equation of a tangent, and finding the equation of a normal. Remember, differentiate for the tangent gradient and use the negative reciprocal for the normal. Good luck with your revision!